Sitting at your desk is making you stupid. That's a blunt way to put it, but the neuroscience is clear. Your posture, your fixed gaze, and your physical stillness are actively constraining the way you think. By the end of this video, you will understand the precise neurological chain reaction that unlocks a 60% boost in creative output from the simple act of walking. You'll know why your best ideas almost never happen at work, and you're likely using the one tool that could solve your biggest problems in a way that completely negates its power. The brain you use when you're sitting still, staring at a screen, is a specialist. It's primed for what psychologists call convergent thinking. This is the process of finding a single, correct answer to a well-defined problem. It's incredibly useful for editing a document, solving a math equation, or debugging code. Your prefrontal cortex, the brain's chief executive, is in full control. It narrows your focus like a laser pointer, filtering out irrelevant thoughts and distractions to execute a task efficiently. It's a state of high beta brainwave activity, a hum of intense concentration. The problem is, this state is the mortal enemy of originality. You can't find a new answer by searching only where the old answers live. The laser pointer is useless for illuminating a room you've never been in before. This is where a famous 2014 study from Stanford University comes in. Researchers Marilio Pezzo and Daniel Schwartz wanted to measure the effect of walking on a different kind of thinking, divergent thinking. This is the ability to generate many possible solutions to an open-ended problem. It's the engine of creativity. They used a classic test called the alternate uses test. It's simple. You're given a common object, like a button or a tire, and asked to come up with as many creative, non-obvious uses for it as possible. The researchers had 4 groups. One group sitting down for the entire test, one walking on a treadmill, one walking outside, and one that walked first, then sat down. The results were staggering. The participants who walked, whether on a treadmill or outdoors, produced on average 60% more creative responses than the group that remained seated. Their ideas were also rated as more novel and higher quality. They didn't just have more ideas, they had better ideas. The simple act of putting one foot in front of the other changed the output of the human brain. But this wasn't just a psychological quirk, it was the physical result of a biological cascade. A cascade that begins with the blood pumping through your veins. When you stand up and start walking, your heart rate increases. This pushes more blood to every part of your body, including your brain. Even a gentle walk can increase cerebral blood flow significantly. More blood means more oxygen and more glucose, the 2 essential fuels your neurons crave. This surge of resources has a curious side effect. It allows the most energy-intensive part of your brain, the hyper-focused prefrontal cortex, to relax its iron grip. It has enough fuel to stop hoarding resources for focused tasks. Its activity quiets down. This state has a name: transient hypofrontality. Transient because it's temporary, hypo meaning less, and frontality referring to the frontal lobe. You are temporarily disabling your brain's inner critic. The part of you that says, "That's a stupid idea," or "That'll never work," is sent on a coffee break. When the chief executive leaves the office, another network quietly comes online. It's called the default mode network, or DMN. You know this network intimately, even if you've never heard the name. The DMN is the daydreaming network. It's the part of your brain that's active when your mind wanders while you're washing dishes, driving a familiar route, or taking a long shower. It's the system that stitches together memories from your past, imagines future possibilities, and combines seemingly unrelated concepts into something new. Think about it. Where do your best ideas actually come from? Almost never when you're staring at a blank page, trying to force a solution. They arrive unannounced when you're doing something else. That's the default mode network delivering a file it has been processing in the background. Walking is a near-perfect trigger for this state. The physical activity is just automatic enough to occupy your conscious mind, letting your subconscious DMN get to work. But that's just the chemical and network level. Something even more fundamental is changing in the electrical rhythm of your brain. Your brain operates on electricity, producing rhythmic pulses called brain waves. When you are focused and alert, like you are at your desk, your brain is dominated by high-frequency beta waves. They are excellent for concentration and execution. When you go for a walk, a different rhythm takes over: alpha waves. Alpha waves are slower. They are the signature of a state of relaxed, wakeful awareness. This is the brainwave state associated with flow, with light meditation, and with the aha moment of insight. The shift from beta to alpha is like changing the entire operating system of your mind. You're switching from a rigid logical processor to a fluid associative one. The laser pointer of convergent thinking becomes the soft ambient light of divergent thinking, illuminating the entire room at once. It's one thing to say you have 60% more ideas. It's another to understand their quality. The Stanford study found that the ideas generated while walking weren't just numerous, they were more novel. One participant, when asked for uses for a button, gave standard answers while sitting: a toy for a cat, a small poker chip. After walking, the same person suggested using a button as a tiny doorknob for a doll's house, or as a way to hold a flower in a lapel. The logic wasn't abandoned. It was augmented. The brain was making more distant, more playful connections. The inner critic was quiet, so the inner child could suggest things without fear of immediate rejection. This isn't just about coming up with quirky ideas for buttons. It's about solving complex, real-world problems that have no single right answer. But the brain's internal state is only half the story. The other half is what your eyes are doing. And this is where walking outdoors gains a significant edge over the treadmill. When you sit at a desk, your visual field is constricted. You are engaged in foveal vision, a narrow cone of focus pointed at a screen 2 feet away. This mode of seeing sends a powerful signal to your brain: attention required. Filter out everything else. It's a biological command to suppress distraction and focus cognitively. Now consider what happens when you walk outside. Your eyes automatically switch to panoramic vision. Your gaze softens. You become aware of your peripheral field of view. You're not looking at any one thing in particular. Instead, you're absorbing the entire scene at once. This is a state neuroscientists call open monitoring. This visual expansion is a direct command to your brain to expand its cognitive focus. You are physically demonstrating the state of mind you want to inhabit. Your brain follows the lead of your eyes. This flood of novel, low-stakes visual information is pure fuel for the default mode network. The shape of a cloud, the color of a door, the way a tree branch has grown around a wire, these are all random bits of data. Your prefrontal cortex at a desk would filter them out as irrelevant, but your DMN, now active during your walk, grabs them. It looks for patterns. It finds analogies. It combines the image of that gnarled tree branch with the management problem you were stuck on an hour ago, and suddenly a new metaphor emerges: an insight. The problem isn't a wall to be broken through, it's a branch that needs to be pruned back to a healthier node. This is why a walk in a visually rich, natural environment is often more fruitful than a walk through a sterile office park. You are giving your creative brain more interesting raw materials to work with. There is, however, one more mechanism at play. It's a simple, mechanical process happening in the rhythm of your own body. Walking is a profoundly rhythmic, cross-lateral activity. When your left foot goes forward, your right arm swings to counterbalance, and vice versa. This constant left-right, right-left pattern of movement forces both hemispheres of your brain to engage in a synchronized conversation. Information has to pass back and forth across the corpus callosum, the thick bundle of nerves connecting your brain's left and right sides. While the left brain logical, right brain creative model is a massive oversimplification, the hemispheres do have different processing styles. The left hemisphere tends to be more analytical and linear. The right hemisphere is more holistic and associative. Walking forces these two styles to integrate. It's like putting your company's most rigid accountant and your most eccentric artist in a room and forcing them to solve a problem together. The result is a solution that is both creative and grounded. This crosstalk is a form of coherence. The entire system is working in harmony, which is often a prerequisite for breakthrough thinking. Critics of this idea often point to the fact that you can have ideas anywhere. And they're right. You can. But you're playing the game on a harder difficulty setting. The Stanford researchers included a group that walked a treadmill facing a blank wall to test this. That group still saw a 40% boost in creativity over the sitting group. This shows the physiological effects of movement alone are powerful. But the group walking outside saw the full 60% boost. The visual input of the external world adds a crucial layer. The movement primes the brain, and the environment provides the spark. The biggest mistake people make, however, is in how they try to harness this power. The creative state generated by walking is fragile. It's a bubble, and most of us pop it the moment we get back to our desks. The creative boost from walking has a brief afterglow. The research shows it persists for a few minutes after you sit down. But the key is to capture your ideas before the prefrontal cortex fully re-engages. The moment you sit, open a laptop, and stare at a blinking cursor on a white document, you are sending a powerful signal to your brain to switch back to focused, convergent, beta wave thinking. The inner critic returns from his coffee break. The DMN goes quiet. The bubble pops. The best way to capture ideas from a walk is to use the lowest friction method possible. Use a voice recorder app on your phone. Talk your ideas out loud as you walk. This keeps you in a state of flow. The act of writing, of structuring sentences, and finding the right words can be enough to knock you out of the creative zone. By recording your thoughts, you preserve them in their raw, unfiltered state. You can edit them later. The goal during the walk is generation. The goal after the walk is curation. Ultimately, this entire process is not a modern life hack. It's a return to our baseline. For 99% of human history, our ancestors thought while they were moving. They solved problems while hunting, gathering, and migrating. The modern office, the chair, the fixed screen, this is the weird 200-year-old experiment. Your body and brain are not designed for it. The lethargy and mental block you feel after hours at a desk are not a personal failing. They are a predictable biological response to an unnatural environment. The walk is not the intervention, the desk is. So the next time you feel stuck, when a problem seems unsolvable and the screen feels like a wall, remember, the answer isn't to focus harder, it's to stand up, open the door, and put one foot in front of the other. The conversation your brain needs to have can only happen when your body joins in. And this principle, using your physical state to deliberately change your mental state, is a lever that controls far more than just your creativity. It can dictate your emotional resilience, your ability to learn, and even how you experience memory itself. A simple change in posture can change the stories you tell yourself, which is a different kind of mechanism entirely.